Today we're going to solve percent problems. Let's start with this. What is 60% of 300? Well, first we know that 60% can be written as a fraction, 60 out of 100. We also know that because we're looking for a percentage of 300, 300 is the whole, not the part. You see, we don't know what the part is, so I'm going to set my fractions up like this. Now it's as easy as asking myself, how would I go from 100 to 300? And that's right, I'm going to have 3 times as many. So 3 times as many denominator, 3 times 100 is 300, and 3 times as many numerator, 60, 3 times 60, which is 180. So I have 180 out of 300 is equal to what out of 300? Of course, 180. And so, we have now shown that 60% of 300 is 180. Now let's look at 60% of what equals 300. So again, 60%. I can write that as 60 out of 100, 100 being the whole, 60 being the part. So 60 100ths of what is equal to 300? The important part now is to identify the parts and the whole. So we know that 60 is the part and 100 is the whole, but what about this 300? Is that the part or the whole? And the part that we're looking for, is that the part or the whole? Think about it. 60% of some number is equal to, yes, 300 is the part, because 300 is that 60% of something else. It is part of something larger. What the larger number is, we don't know yet. But now we can think about how to go from 60 to 300. And if we multiply 60 by 5 and 100 by 5, then we will have a numerator that is the same as our 300, which will then help us know what our denominator is. And yes, 60 times 5 is 300, and 100 times 5 is 500. And so, 300 out of 500 is the same as 300 out of what? 500. And so, we've shown that 60%, the part, of 500, the whole, is equal to the part 300. Now what about this? 60 out of 300 is equal to what percent? 60 out of 300. Well, 60 is the part because it's coming out of a larger whole, which is 300. So here's our part and our whole for our value. But what about our percentage? What is the part and the whole there? Do we know either? Yes, of course, we always know what the whole is for a percent. It will always be out of 100. So now we're trying to figure out the part of the percent out of that whole. And to do this, we only need to make the value of the numerator or denominator the same as our other fraction, and then we can find our missing part. So, how do we go from 60 to question mark? We can't, because we don't know what the question mark is. How about from 300 to 100? How can we do that? Yes, by dividing by 3. 300 divided by 3 is 100, and the numerator, 60 divided by 3, will be 20. So now we have 20 out of 100, which is equal to what percent out of 100? 20%. 60 out of 300 is 20%. Priya is doing some back-to-school shopping. I'm going to give you some items that she has bought, and how much she's saved and the total cost and percentage, and I want you to calculate the missing part of my statement. So for instance, Priya bought a shirt. It was 25% off, and its original price, before the 25% off, was $44. So, how much money is that 25% off? First thing is we need to identify the parts and the whole. So, take a look at the 25% discount. Is that whole or part? Well, of course, that's part, because if we're talking about percentages, the whole would be 100. So that's 25 out of 100. What about the original price, $44? Is that part or whole? That has to be the whole, because something is going to be taken out of that $44. That's what we're looking for. And so, our percentages and our fractions and ratios can be set up like this. We don't know the part to take out of $44 yet, but $44 is the whole. We do know the part of the percentage, 25, taken out of the whole, 100. So, now let's look at it. Can we go from 44 to 100? I can't think of any way. So instead, I'm going to simplify my 25 out of 100 by dividing both numerator and denominator by 25. This will leave me with 1 over 4. 25 divided by 25 is 1, and 100 divided by 25 is 4. And now our question is, can we go from 44 to 4? Yes. If we multiply 4 by 11, or we could have divided 44 by 11 as well, but I'm going to multiply my numerator and denominator, 1 over 4, by 11, and end up with 11 over 44. Now you tell me, what is the numerator of the cost? So, the shirt costing $44 originally, with a $25 discount, saves you $11. Okay, Priya is also buying some pants at a 30% discount. The original price is, we don't know, but we do know that that 30% discount was $15 off. Now how do we find the original price? Well, first we need to set up our fractions. What are the parts and what are the wholes? The 30%, is that part or whole? That's the part, and the whole would be 100. What about the $15? That discount, is that the part or the whole? That's the part, so that will be our numerator. Or what's the whole? The original price, and we don't know that, so let's set up our fraction. And so here it is. Here is our 30%, 30 out of 100, and our $15 discount out of, we don't know yet, the original price. So, can we go from 100 to question mark? No, we can't do that. How about 15 to 30? Yes. We can either multiply 15 by 2, although that won't help us because multiplying a question mark by 2, we don't know what to do. So instead we're going to divide 30 and 100 by 2, which will give us 15 out of 50. And 15 out of 50 is equivalent to 15 out of 50. And so the pants, at a discount of $15, which was 30% off, originally cost $50. Now, I want you to try this on your own. Shoes, at a 15% discount. What is their original price if that 15% discount is $9? Another item bought was a necklace at a 10% off discount. Now, its original price was $20. How much did she save from that 10% discount? Lastly, there is a sweater that's 20% off. We don't know its original price, but we do know that that 20% discount saved her $7. What is the original price? And now I want you to find the total cost of Priya's outfit. Let me give you a table to help you out. Here are all 5 items we discussed. Here are their original amounts and the amounts of the discounts. I want you to tell me how much she paid for all 5 of these items together. If an item is 20% off, then that sale price is what percent of its original price? So, an item is discounted 20% off. That means we are taking 20% of the cost away from the original price of the item. Now, I'm setting it up like this to say that the item subtract that 20% is going to be the cost that we actually pay. This helps because we know that the item is 100%, right? An original price of anything is going to be 100%. Now, we are taking away 20% of that before we pay for it because it's 20% off. So, what is the percent that we actually are going to pay? Not 100%. Rather, we are ending up paying only 80% of the original item. Remember, the item, whatever it costs, at original state is 100%. If it's 20% off, then that means we're going to take away 20% from 100 and only pay 80. This helps us because if we are asked for the amount of the discount if the original price is $400. We can now use our 80% and our 20% and our 100% knowledge to solve this. Again, the item's original cost was $400, so I'm going to line that up with my 100%. What I don't know yet is how much the 20% is, nor do I know how much the 80% is. But can we find this out? Of course we can. All we need to do is match up our parts and our whole. So 100%, is that part or whole? Yeah, that's whole. So what is whole on our cost? That would be the $400. That's the original whole price. What else do we know? Well, we know that 20% is part taken away. So that is going to equate with the part that's taken away from our $400. And so we can set it up like this. 20%, or 20 out of 100, is equal to some number out of 400. So, how do we go from, let's say, 100 to 400? We could multiply both the 100 and 20 by 4, and we will have common denominators. And now we have a fraction of 80 out of 400, which is equivalent to what out of 400? Of course, it's 80. So 20%, or 20 out of 100, is equal to $80 out of $400. You see, 20% off, $80 is the cost that we do not have to pay. We're paying the 80%, not the 20. And now it's a simple arithmetic. $400 total cost, original. Take away 20%, which happens to be $80, is equal to how much? Yes, $320 is the actual final cost after the 20% is taken away. You know, we could have gone about this differently. Let's take a look. Remember when we had it set up like this, and we talked about what is the whole and what is the part? Well, we decided to go with the 20% out of something we didn't know. But wouldn't it be just as fine if we were to take the 80% part out of the whole 100? Watch. So, 80% is 80 out of 100, and that's equivalent to some amount out of 400 that we'll end up paying. So how do we go from 80 out of 100 to something out of 400? We multiply by 4, because 100 times 4 is 400, and 80 times 4 is 320. And so 320 out of 400 is equivalent to what out of 400? Yes, again we find that 80% is equal to 320. This is the part that we will pay. Now, here is another table showing you some items that were bought. I want you to take a look at it and fill in the missing information. Determine what 10% of 300 is. Find 10% of 80. Determine 10% of 64. Find 10% of 5. 10% of what is 48? 10% of what is 6? Gary read 34 pages of a 340-page book. What percentage of that book did he read? Micah read 16 pages of his book. If this is 10% of the book, how many pages are in the book? Sam purchased 3 games for $140 after a discount of 30%. What was the original price? If Sam had used a 20% off coupon and opened a frequent shopper discount membership to save him 10% more, would the games still have been $140 total? So what have we learned today? Wrapping up our teaching on percent, we know that percent problems have 3 parts. We are always dealing with a part and a whole and a percent, which is a part and a whole also. And lastly, we know that percent problems can be solved using various types of models.